All right, thank you for joining us today. And in this video, we have 8 set questions that we are going to go through together. So stay here with me. Okay, so let's start. So the first question, we want to find dy over dx of the following functions. And we move to the second question, right? All right, so let's pick from A. So we have A, which is y is equal to 5x squared e to the power 3x, right? So what rule are we going to use? So we can see that here we have two functions. Let's say this function and this function. So we need to use the product rule. So let's assume that this is the same as AB, right? Then what is A? Let's choose A to be 5x squared and let's choose B to be e to the power 3x. Then what is A prime? A prime is equal to, so I maintain my 5 because 5 is a constant multiplying the function that we want to differentiate. So now when I differentiate x squared, what am I going to get? 2x, which is going to give us 10x. Now what is b prime? Now we know how to differentiate an exponential function. I maintain the function, then I take derivative of the top, which is 3x. Good. So when I do that, I'm going to have e to the power 3x times, when I differentiate 3x, I get 3. And when I simplify, I'm going to get 3e 3x. So that was what I'm going to get. So we know that by the product rule, y prime is going to be either a b prime plus a prime b, right? So this is what you are going to get from the product rule. You can also do it straight. If you know how to do it straight, you just go ahead and just do it, right? So let's do that. What is A? A is 5x squared. What is B prime? B prime is 3e 3x, right? So A and then B prime is here, right? Plus what is A prime? This is A prime, right? So 10x. Then what is B? This is B. So we are going to have E3x. So when I simplify, I'm going to have 3 times 5 will be 15 x squared e to the power 3x plus 10x e to the power 3x. So this is going to be my y prime. You can also do it straight without picking A and B. If you know how to do it, you just go straight. So here, the idea is that if I want to do it straight here, you maintain this, right? Then you differentiate that, what is here, plus now I maintain this one, which is here, and then I differentiate this, which is 10x. So the same thing. So this is the first one, which is A. Let's look at B. So B, we have y equals 3x to the power 5. Then we have 5 minus x squared to the power 4, right? Good. So we have product rule again, right? So with product rule, I always love the idea of picking my A and picking my B, with the idea that anytime I pick my A and I pick my B, it helps me to differentiate the function and make no mistake, right? So I'm going to pick A to be 3x to the power 5, and I'm going to pick B to be 5 minus x squared to the power 4. So now what will be A prime? Let me shift B small so I can shift B here. 5 minus x squared to the power 4. What is A prime? A prime, let's use the power rule. So the 5 will drop down to multiply the 3, which is giving us 15, right? Then x to the power 5 minus 1, which is going to be 4, right? What is B prime? Now B prime, this is the change rule, right? But we are going to use the short way. So 4 drops down. So the 4 drops down. I maintain the whole function, which is 5 minus x squared to the power 4. But this is the power rule. Anytime you drop something down, you are using the power rule. So we need to subtract 1. So I'll subtract minus 1. Then I'll multiply it by the derivative of what's inside of what? The parenthesis. So what is inside the parenthesis is this, which is 5 minus x squared. Right. So when I simplify, I'm going to have 5 minus x squared to the power 3 times. Now when I differentiate 5, I'll get 0. When I differentiate 2x squared, I'm going to get 2x. So this is going to give us times minus 2x. And then if I want to simplify this, I'm going to have minus 2 times 4 is going to give us minus 8. Then I have my x here, so times x, then 5 minus x squared to the power 3. So this is the derivative for b, which is using the chain rule, right? Good. So we have b prime, we have a prime, we have a, we have b. So we can now look for y prime. So y prime is maintain a, differentiate b, plus maintain b and differentiate a. So that is the product rule. So now this is equal to, what is a? A is here. So I'm going to have 3 times, what is b prime? This is b prime. So I'm going to have something like this. 5, so minus 5 minus x squared to the power 3 plus, what is b? B is here, and then this is a prime. So I'm going to have plus 5 minus x squared to the power 4 times a prime, which is 15x to the power 4. So when you are doing it straight, if you know how to do it straight, this is how I did it. So I maintain this, which is here, and then differentiate this. So when you differentiate this, you are going to get what is here, right? Plus, now I maintain this, the one that I differentiated, then I differentiate this, and this is what I'm going to get. So you can skip the whole of this if you know how to do it, and skip this one and just write it straight away. But the idea is that if you are doing it straight like this, if you don't be careful or if you don't take care, you will get it wrong. So if you know how to do it, you can go straight, but it's good and advisable to pick your a, b, a prime, and then b prime. Then when you finish, you just use this idea and then you are done. So let's see if we can do some simplification here. I can multiply 8 and 3 and x here. So this is going to give us minus 8 times 3 is going to give us, I think, 24. Yeah. So 24. Then x to the power 5 times x is going to give us x to the power 6. Then 5 minus x squared to the power 3 plus, when I multiply this, I can just bring this one forward. So I'm going to have 15x to the power 4, 5 minus x squared to the power 4. So this is what you are going to get for the b when we differentiate it, right? So what did I do? I pick my a, I pick my b, right? Find a prime, find b prime, then a multiply b prime, b multiply a prime. That is the product rule. Good. So that is the b. Let's look at c. So with c is going to be interesting. So c, y is equal to ln of x plus x divided by x squared plus 3, right? So this one, the first question that you need to ask yourself is, which rule are we going to use? We need to use the quotient rule, right? So this is going to be u divided by vin. I like u and vin with the quotient rule, and then I also like a and b with the product rule, right? So what are we going to do? It means that u is equal to ln of x plus, let me shift it small, u is equal to ln of x plus x, and then vin is equal to x squared plus 3. So that is the idea here. So u is this, and then vin is this. Then we know that the quotient rule, we will need u prime, and we are going to also need vin prime. So what is vin prime? When I differentiate vin prime, when I differentiate x squared, I'm going to get 2x. When I differentiate 3, I'm going to get 0. So we just go to 0. Now let's come here. When I differentiate ln x, what am I going to get? So by this time, you should be able to know how to differentiate a ln function x, right? So when I differentiate ln x, I get 1 over x, but know the process, right? So that if it's not just ln x, you know what to do. So to differentiate ln x, is 1 over x times the derivative of what is inside the parentheses, right? So 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses. Then plus when I differentiate x, what am I going to get? 1, right? So what are we going to get for Vim prime? Let me put it here. So Vim prime will be equal to, when I differentiate x, I'm going to get 1. 1 times this is going to give us 1 over x plus the 1, which is here, right? So when I differentiate this, when I differentiate x, I get 1. So 1 times 1 over x is 1 over x plus the 1. So this is going to give Vim prime. So now what is y prime? Y prime is then u prime minus u Vim prime divided by Vim squared, right? So maintain the denominator, differentiate the numerator, minus, now maintain the numerator and differentiate the denominator, all divided by denominator squared. So that's what you are going to get. So as soon as I choose my u Vim, I have my u prime, Vim prime, and I know my formula. The rest is just substitution, because this is the one which is the hard work that we need to do. So we are done with the hard work. The rest is just doing substitution. So what is Vim? Vim is this. What is u prime? U prime. Oh, I think this one's supposed to be u, not Vim. So this is u. Good. So this is u prime. Good. So we are going to have Vim is x squared plus 3 times u prime is 1 over x plus 1 minus, what is u? U is here. So in brackets, ln of x plus x, then times Vim prime. Vim prime is 2x, all divided by Vim squared, which is x to the power 2 plus 3, all to the power 2. Right, so that's what we are going to get. Let's see if we can simplify, or we just need to leave it like that. Right, so let's see. We can just leave it like that because nothing is going to cancel. But okay, let's just simplify and see. So if I want to simplify, this will multiply this, which is going to give us x, because x squared times 1 over x is x. 1 of x will cancel. Then x squared plus x is going to give us x squared. 3 times 1 over x is going to give us 3 over x. Then 3 times 1 is going to give us 3. So I multiply this by this. I multiply this by this. Multiply this by this. Multiply this by that. Right? Then minus, then open bracket, I need to multiply this by this and this by that, right? So I'm going to have 2x ln of x plus 2x squared. So this times this will give us this, and this time this will give us this, all divided by, there is no need for us to expand the denominator, right? So this is going to give us, now I'll multiply this one through, and I think still nothing is going to cancel. X squared plus this plus 3 minus 2x ln x minus 2x squared divided by x squared plus 3 all squared, right? And finally, we are going to get something like this. So the only thing that we can simplify here is this and that. So we are going to have x plus 3 on x plus 3 minus 2x ln x minus, so this and this is 1. So 1 minus 2 is going to give us minus 1. So it's going to be minus 2x squared minus x squared, and then x squared plus 3 all squared. So this is what you are going to get from that. But I think you can also leave your final results here if you don't want to go through this hard work again, because you might even get wrong somewhere. So you can just leave it this form and you are okay to go. Right. So that is what is giving us like the C. That's what you are going to get for the C. Now let's look at the D. Right. Let's look at the D. Let's look at the D. D is we have y is equal to 3x minus 5 x squared divided by 2x minus 1. So this is also the quotient rule. So I choose my u, I choose my vin, right? So what is u? U is equal to 3x minus 5 squared. And what is vin? Vin is 2x minus 1, right? We need u prime, we need vin prime. So what is u prime? We need to use the change rule by the short ways, right? So 2 drops down. I maintain the whole function. Then I subtract 1 from the top, right? Then times, now I differentiate what is inside the parentheses. D over dx times what is inside the parentheses. Good. Then when I simplify, I'm going to have 2, 3x minus 5. The top will be 1, which is the same as that. Then when I differentiate 3x minus 5, I'm going to have 3. And then when I simplify, I'm going to have 6, 3x minus 5. So I'll just leave it this form. Yeah. Then what is vin? We saw that vin is equal to 2x minus 1. So what is vin prime? Vin prime is just 2. When I differentiate 2x, I just get 2. When I differentiate minus 1, I get 0. Right. So now using the quotient rule, let's see what you are going to get. Y prime is equal to vin u prime minus u vin prime divided by vin squared. So if I just know the formula, I just quote it down and just do substitution. So we are done with the hard work. The rest is substitution. So vin is this times u prime is this. So we are going to have 2x minus 1 times 6 3x minus 5 minus u is this times vin prime is that. So we are going to have 3x minus 5 all squared times 2, all divided by vin squared. Vin is 2x minus 1 squared. So let's see if we can do some small simplification. Yeah. So we can do something like this. I can move the 6 in front. So I'm going to have 6 2x minus 1 3 minus 5 minus 2 3x minus 5 squared, all divided by 2x minus 1 all squared. So what did I do? I just moved this one. Since it's multiplying this and this, I just moved the 6 here. Then I wrote this one. I wrote this one too. Minus, I just moved the 2 in front. Then I wrote this one divided by this. So this is where we are going to end the solution. We don't need to simplify anything again. Right. So that will be the D. That will be the D. That will be the D. Right. So first I saw that this is the quotient rule, and then I pick my u, I pick my vin. I know how to differentiate individual functions, so I just go through that. I code down my formula here and I just do substitution. Right. So now let's look at E. Let's look at E. Good. Let's look at E. So with E, we can use two methods to do it. But so E, y is equal to 3 divided by root of 3x squared plus 1. So as I said, anytime you see a radical or a root, you need to simplify it. So this one can be written as 3 divided by 3x squared plus 1, and then the root will change to 1 over 2. So this one, we can use the product rule. Sorry, I said product rule. We can use the quotient rule, or we can also use the idea of changing this one so that we can use the change rule. But I'm going to use the quotient rule to do this. So this is, we have something over something here. So this is u divided by vin. But don't forget, I can also change this one as, okay, so let me finish. When I finish, I will just show you how you can also change this one and differentiate, right? So what is u? U is equal to 3. What is u prime? U prime will be 0, because when I differentiate a constant, I need to get 0. What is vin? Vin is 3x squared plus 1 all to the power 1 over 2. So what is vin prime? Using the change rule, I drop the 1 over 2. I maintain the whole function. 1 over 2, then I subtract 1. Don't forget, whenever you are using the change rule, the first one is you are applying the power rule. So you drop 1 over 2, you maintain the whole function, and you subtract 1. Then now you take the derivative of what is inside the parenthesis, which is 3x squared plus 1. Right, so what are we going to get? We are going to have 1 over 2, 3x squared plus 1. 1 over 2 minus 1 is minus 1 over 2. Then when I differentiate x, 3x squared plus 1, I'm going to have 6x. Good. So what can I do? Half of 6 is going to give us 3. So this one can be written as 3x, right? Half of this is going to give us this. Then I have 3x squared plus 1 to the power minus 1 over 2. So let's go through the quotient rule. So I have y prime to be equal to so I'm going to have something like this. Then u prime minus u vn prime divided by vn squared, right? So the more you solve example, you will see that you remember this formula here. You will remember how to do this, right? So the more you solve example, you will see that now you will be able to even do it without quoting your u and vn, right? Good. So what is vn? Vn is 3x squared plus 1 to the power 1 over 2. What is u prime? U prime is 0. Minus, what is u? U is 3 times, what is vn prime? Vn prime is here. So we are going to have 3x squared plus 1 to the power minus 1 over 2. Close the bracket. All divided by vn squared. So 3x squared plus 1 to the power 1 over 2 all squared. Good. So let's try and simplify this. Now 0 times this will be 0, right? So now I'm trying to simplify this one here. So I can multiply the minus 3 to this one. So I'm going to have minus 9x 3x squared plus 1 minus 1 over 2 divided by, this 2 will cancel this 2 here. So I'm going to have something like 3x squared plus 1. Yeah, so it will just going to be like something like this. Can we do something here? I think we can just leave the final results here. The only thing that we can do is we can just bring this one down. Yeah, but you can also leave it that way. So this one is going to give us minus 9x divided by 3x squared plus 1, then times 3x squared plus 1. But this is going to be 1 over 2. Right. Because I brought this one down, so the sign will change to positive. Then the only thing I can also do again is I can just since the base are the same, you can see that what is here is the same as this, so we can see that that's the same base. So I can, this is 1, so I can add this one to this, and then I'm going to get something like minus 9x divided by, so since the base are the same, I add the top, so 1 plus this is going to give us 3 on 2. So we are going to have something like 3x squared plus 1, 3 divided by 2. So that's what you're going to get at the end of the day. And then if you want to go a little bit further, then this is minus 9x divided by root of 3x squared plus 1 to the power 3. So this one, if you cannot see it, it's okay. Because what I can do here is I can factor 3 out. So this one will be 1 over 2, or let me see, I can multiply this one by 3, and then this one will be like this. So 1 over 2 here, and then I'll use it. So this is what I mean. This one can be written as 3x squared plus 1 to the power 3 times 1 over 2, right? So if I put this one in parentheses, this 1 over 2 can be written as square roots. So that's what we have gotten here. But I think you can just leave your final results in this form if you don't know how to do this simplification, right? Then I was also saying that from here, if you don't want to use the quotient rule, I can rewrite this one as, because this is constant, I can rewrite this one as y is equal to 3x squared plus 1 to the power minus 1 over 2. So I can just move this one to the top. to multiply this, but I'll change the sign. Here is plus, I'll change it to negative, right? And what am I going to use? I can use the chain rule to do that. So this 1 over 2 will multiply this. I subtract 1, and then I do the same process. So let's see if we are going to get the same results when we are using this one too. Let's see. So this is going to be 3. I drop minus 1 over 2, right? When I drop minus 1 over 2, I maintain the whole function. Don't forget 3 is here. So I maintain the whole function here. So I'm going to have 3x squared plus 1, then minus 1 over 2 minus 1, right? Times, now I differentiate what's inside the bracket, what is 3x squared plus 1. I close my bracket here. So what am I going to get at the end? I'm going to have this 3 can multiply this, so I'm going to have minus 3 on 2. Then I'm going to have 3x squared plus 1 minus 1 over 2 minus 1 over 2 is going to give us minus 3 on 2. Then when I differentiate what is inside the bracket, I'm going to have 6x. Right. So when I multiply 2 by this will be 3. So 3 times 3 will be 9. So we are going to have minus 9x. And then since this is minus, I can bring it down. So I can write this one as 3x squared plus 1 to the power 3 on 2. So if I don't want to do further simplification, you can see that what is here is the same as what is here before I move to this side, right? So like differentiation techniques, we have ways of doing it, and it's going to work when you do it right. So this is another way of differentiating the e. Right. So now that we are done with e, let's look at f. Y is equal to e to the power 4x minus x squared. This is an exponential function. We know how to differentiate an exponential function, right? So what is y prime? Y prime is equal to maintain the function, which is e to the power 4x minus x squared, then differentiate what is on the top, which is 4x minus x squared. So I maintain the function here. I multiply it by the derivative of what is on the top, and I have this. So now what am I going to get? E to the power 4x minus x squared times, when I differentiate what is inside the bracket, what am I going to get? 4x gives me 4, x squared gives me 2x. Then just if I multiply, I'm going to have 4 minus 2x times e to the power 4x minus x squared. So this is what I'm going to get when I differentiate this function. Very simple. Right. Let's look at gene. So what are we differentiating? Y is equal to ln of root of 2x to the power 3 plus 3x squared minus 1, right? And then, as I said, anytime you see square root, make sure you change it, right? So this can be written as ln of 2x to the power 3 plus 3x squared minus 1 to the power 1 over 2. Then if I'm using the ln property, I don't want to suffer, right? So if I'm using the ln property, I can move this one to back of this. So I'm going to have 1 over 2 ln of 2x cubed plus 3x squared minus 1. So that now my function becomes, so you see the way I've simplified the function from here to here and here. So that now I can differentiate y prime. So now that we are coming to differentiate y prime. So don't forget 1 over 2 is just a constant. So I bring it out. Now the function that I need to differentiate is this. So when you differentiate a ln function, what do? 1 divided by what's inside the parenthesis, which is 2x cubed plus 3x squared minus 1, all times the derivative of what is inside the parenthesis, which is 2x cubed plus 3x squared minus 1. I close it. Then let's see 1 over 2x cubed plus 3x squared minus 1. Then when I differentiate this, what am I going to get? Differentiate 2x to the power 3 and we get 6x squared. So I drop the 3 to multiply this, giving us this. Then I subtract 1 by the power rule. Same thing, drop 2 to multiply this, subtract 1. So we are going to have plus 6x, and then when I differentiate a constant, I get 0. So what can I do now? So we can see that I can factor 6 out, right? And then I use to multiply this. So I'm going to have 1 over 2. So when I factor 6 out, I'm going to have 6x squared plus x divided by 2x cubed plus 3x squared minus 1. I factor the 6 out so that 2 can cancel the 6, and then we are going to have 3x squared plus x divided by 2x cubed plus 3x squared minus 1. So this is what you are going to get from the ln function. So what did I do? First, you need to make your life simple. We change this one to 1 over 2. And because of the ln, that's the reason why we were able to bring this one behind this, right? Good. So we brought this one because if you don't do that, your differentiation is going to be complicated. So because you are going to have 1 over 2, this to the power 1 over 2, then this to the power 1 over 2. You need to cancel it, do the cancellation and everything. You are going to get the same result. But this is a simple way of doing it so that you have your half in front here. Right. Now let's look at the last question in question 1. So now we need to differentiate y is equal to root of 2x minus 3x squared. So now it is not hard to show that this is the same as 2x minus 3x squared all to the power 1 over 2. Right. Here there is no ln function, so I cannot move the 1 over 2 here as I did for the one that we did here. Right. This one there's a ln function, so I was able to move this one here. This one there is no ln function, so this is what I'm going to get. So now what is y prime? Using the chain rule, drop the 1 over 2, maintain the whole function, subtract 1, then differentiate what is inside the parentheses, which is 2x minus 3x squared. Right. So this is going to give us 1 over 2, 2x minus 3x squared. Then this is going to give us minus 1 over 2. When I differentiate what is inside the parentheses, I get 2 minus 6x. Right. So that's what I'm going to get using the power rule. Can I do something? Yeah, I can just do something small, but you can leave your answer in this form if you cannot do further simplification, right? So what I can do here is I have 2 here, I have 2 here. No, I have 2, I have 6. So I can factor 2 out, right, from here. So when I do that, I'm going to have 1 over 2. When I factor 2 out, I'm going to have factor the 2 out. When I factor the 2 out, here will be left with 1. When I factor 2 out, here will be left with 3x. Then times 2x minus 3x squared to the power minus 1 over 2. Then this 2 cancel this 2. So I'm going to have 1 minus 3x times 2x minus 3x squared minus 1 over 2. If you want to go a little further, then 1 minus 3x divided by 2x minus 3x squared to the power 1 over 2. So the sign changes to positive when I go it down. Yeah, so this is what I'm going to get for h. Right. So we are done with the first question, the differentiation. Let's move to question 2. Now, question 2, find the equation of the tangent line to the graph this. Right. So we want to find the equation to this tangent line here. What are we going to do? Okay, so for us to find the equation of the tangent line, the first thing that we need to do is we need to write down the formula, right? So here, the only hard work that we are going to do is how to figure out the slope. So what is the equation of the tangent? Y minus y1 is equal to mx minus x1. This is the equation of the slope. Now, I told you that anytime you have this and you have this point and you are talking about the equation of the tangent, this point here is x1 y1. So this is my x1, this is my y1. So let's do substitution. So I'm going to have y minus 1 is equal to m x minus 4. So I'm going to have y plus 1, which is equal to m x plus 4. So you see, this is not hard work. The only hard work that we are going to do is to find m, right? So let's now go and look for m, because that's the only thing that we need, and we are done. So how do you find m? Don't forget, m is the same as dy over dx. So that's what we need to look for. So since we have this here, then remember, y squared plus xy minus plus 3 is equal to 0. You can see that that's why we need to use implicit what? Differentiation. Why? Because the power here is squared, and we have also another function y attached to x that we cannot make y the subject. So let's use implicit differentiation. Now when I differentiate y squared with respect to x, what am I going to get? I'm going to have 2y dy over dx, right? So I'm thinking of differentiating x squared. Like I'm assuming that this is x squared, and we know that when you differentiate x squared, you get 2x. So when I differentiate y squared, I get 2y, right? But here, because implicit differentiation, I need to multiply this one by dy over dx. Then plus implicit differentiation, this is a product rule. So I maintain x, then when I maintain x, differentiate y, so dy over dx, plus now I maintain the y and differentiate x. When I differentiate x with respect to x, I get 1. Listen, x with respect to x, so it will cancel out to get 1. Then when I differentiate a constant, I get 0. Right. So as I also said, this point here that we are seeing that is x1 and y1 for the equation of the tangent. The same point becomes x and y for the slope. Anytime you are finding the slope, the point given here now changes to x and y. So now -4 and -1 now changes to x and y whenever you are dealing with the slope, not the equation of the tangent line. Right. So now I can do substitution. 2 times y is -1 dy over dx plus x is -4 dy over dx plus y is -1 times 1, and this is 0, so we get 0. So this is going to give us -2 dy over dx minus 4 dy over dx minus 1 is equal to 0. This is what we are going to get. Now this and this are the same, so we add the coefficient. So -2 minus 4 is going to give us -6 dy over dx. Then I will move -1 is equal to 0. So what I'm going to do is I'll add +1 here, +1 here, +1 here, +1 here. So I'm going to have -6 dy over dx, which is equal to 1. Then I'll divide 2 by -6, divide this one by -6. So this implies that dy over dx is equal to -1 over 6. So this is the hard work, right? How to get the slope. That's the hard work. So we've done the hard work. So the rest is just come and do substitution. So we are going to plug in 1 over 6 there, and then we are done. So what are we going to get for the slope? We are going to have, let me just write it here. Where can I write it? Okay, let me bring it here. So from here, I'm going to have y plus 1 is equal to, we had -1 over 6. So -1 over 6 x plus 4. So this will be the equation of the tangent line. Equation of the tangent line. So you see, the only hard work here is how to find dy over dx, your slope, and then you are done. Good, good. Now let's move to the next question. So next question, we have a polynomial function here to the degree 6, and you want to find the interval for increasing and decreasing, local minimum and maximum, and then we sketch the graph. Nice. So we said that for us to talk about increasing and decreasing and local maximum and minimum, the first thing that we need to do is we need the critical values. That is the x values that makes the tangent line equal to 0, or f prime to be equal to 0. So the first thing that we need to do here is we need to differentiate the function and we find the critical values, right? So given that f of x is equal to 6x to the power 6 minus 3x to the power 4 plus 3x squared minus 5, what is f prime? This is a polynomial function, so we use the power rule. Differentiate x to the power 6 and we get 6, 5 minus, differentiate this, 4 multiplies this, we subtract 1, so we are going to have 12x to the power 3. 2 drops down to multiply this, we subtract 1, we get plus 6x. Then when I differentiate a constant, I get 0. Good. So now that we are done with the differentiation, now we need to do factorization in a such a way that we will see the x values that will make f prime to be 0. So what I can see from here is I can see that 6 can go here, 6 can go here, 6 can also go here. So I can pick 6 out. I have x here, I have x here, I have x here. I can also factor x out. So what will be left? When I divide this one by 6x, 6 will cancel x, 6, and one of the x will cancel this. So this one is going to be left with x to the power 4. When I divide this one by the 6x here, 6 will cancel this, which will be left with 2. One of the x will cancel this, which will be left with x squared. So this will be minus 2x squared plus, when I divide this one by 6x, 6x will cancel 6x, so this one will be left with 1. Wow. So this is what we are going to get. Now, another hard work that we need to do is now how we are going to find factors of this. This is to the power 4, but it is not hard to see that this is going to give us x squared plus 1. No, it's supposed to be minus because it's minus there, and then x squared minus 1. Good. So how did I see that? This one is to the power 4. So I need to break it in a such a way that I have two quadratic functions, right? So x squared, this is 2, this is 1. So now x squared times s squared will give me this, right? So let's expand and see if it is true. X squared will give us this. So this time this will give us that. This time this is going to give us minus x squared. This time this is going to give us minus x squared, and then this time this is going to give us plus 1. So I have this one here, I have this one here. When I add minus x squared minus x squared, I get minus 2x squared. So yeah, that's what we are going to get. Now we can also see that this here is like difference of two squares. So we can write this one as x plus 1, x minus 1. This is the same as this. So we are also going to have x plus 1, x minus 1. Good. So this is the hard work that we need to do here. If we are not able to see this, it means that you will not be able to find the critical values. Now let's see how we can get the critical values. So for critical values, f prime of x should be equal to 0, right? So what are we going to do? We are picking everything here and then we set it to 0. So 6x, x plus 1, x minus 1, x plus 1, x minus 1 is equal to 0. So I pick this one, I set to 0. So 6x is equal to 0. It means that x should be 0. I pick this one, I set to 0. X plus 1 is equal to 0. It implies that x should be negative 1. I pick this one, I set to 0. X should be equal to 1. But when I pick x plus 1 and set to 0, is the same as this. When I pick this one and set to 0, is also the same as this. So here, the critical values are 0, minus 1, and 1. These are the critical values. So now that we have the critical values, now the question now is asking us to find for increasing and decreasing. So we need to use the sign chart, right? So let's go ahead and use the sign chart. So we have the sign chart here. So what are the critical values? We have 0, minus 1, and 1. So minus 1 is the least one. So I'll put my minus 1 here. I put my 0 here, and I put my 1 here. Good. So what we are going to do is, what is f prime? F prime, let me write f prime here so that we can see what I'm going to do. So f prime of x is equal to 6x, x plus 1, x minus 1, x plus 1, x minus 1, right? So what I'm going to do is, remember, whenever we are using the sign chart, we use f prime of x. So that's the reason why I have this one here. So pick any value here, plug it in the f prime. Any value here, any value here, any value here. So I'll just write them here. So this is f prime, we can pick -2. This one we can pick, so because this is -1 and 0, we can pick something like -0.5, right? And then here we can pick something like 0.5, and then we can pick something here too. Prime. Good. So what we are going to do is we plug this one inside and check whether it is decreasing or increasing, right? So let's plug -2 inside this. So the idea is that when I put, I just want to see whether I'm going to get negative or positive, right? So when I put -2 here, when I multiply -2 by 6, I'll get -12. So that is -12. It's minus. We want the signs. When I plug in -2 here, -2 plus 1 is -1. So that one too is minus. Then when I plug in minus here, -2 minus 1 is also minus. The same minus here, the same minus here. So let's multiply all the minus and see. Minus is positive. So this is going to give us positive. This is also going to give us positive. So positive, minus. Then positive times positive is going to be positive. And then positive times minus is going to give us minus. So it means that here we are going to have minus, meaning that the function is going to decrease, right? It means that the function is less than 0 because it's minus, right? So you can just plug it in. Now let's go for 0.5, right? So as I said, -0.5, plug -0.5 here, and we are going to have minus, right? Because when I multiply minus by positive number here, I'll get minus. Then -0.5 plus this is going to be positive. Then minus here is also going to give us minus, because -0.5 minus 1 is minus. Then -0.5 plus this is also going to give us positive. And then same for this one is going to be minus, right? So what can you see? Minus times positive is minus. Minus times minus, this one is not 1, it's just minus. So minus times positive is minus. Minus times minus is positive. Positive times positive is positive. Positive times minus is minus. So this is also going to be less than 0, meaning that we are going to have minus, and this is going to decrease. Now let's plug in 0.5, which is positive. So positive value times positive value here will be positive, right? Then when I plug in 0.5 here too, we are going to have positive, because 0.5 plus 1 is positive. Then when I plug in 0.5 here, I'm going to have minus. Then here is also going to give us positive, and this one is going to give us minus. Good. So positive is positive. Positive times negative is negative. Negative times positive is positive. Sorry, it's negative, and negative times negative is going to give us positive, right? So this is going to be greater than 0. So this is positive and is going to increase. Then 2, this is positive. So let's go through 2. That's the last one. When I multiply 2 by 6, I'll get positive. 2 plus 3, 2 plus 1 is positive. 2 minus 1 is positive. 2 plus 1 is positive. 2 minus 1 is also positive. So positive times positive is positive. So this is positive, also increasing. This is greater than 0. So now that we have this, now we are going to do what we need to do. So we need the increasing and decreasing interval. So automatically we can see that this is decreasing, this is decreasing, this is increasing, this is also increasing. For the decreasing interval, we are going to have, so it's decreasing up to -1, starting from -infinity. So this is -infinity -1, and then we have decreasing in between -1 and 0. So we are going to have -1 and 0. So this will be the decreasing interval. Let's look at the increasing interval. So with the increasing interval, we can see increasing. The first increase is between 0 and 1, and the last increase is between 1 and positive infinity. So this is going to give us 0, 1, and then 1 and positive infinity. So this will be the A from the increasing and decreasing. Now we can also use the same sign chart to find for the local minima and local maxima. But we said with the local maxima, B, we made mention for the local maxima, if it is maxima, it is plus minus, meaning that for us to see it, we need to see something like increasing and then decreasing. And for the local minima, we need to see something minus, which is decreasing, and then positive, which is what? Increasing. So let's go to the sign chart and see. So do you have anything like positive, negative? Positive, that comes, and negative. So we can see positive here, but the next one is positive. So we cannot say anything about this. So we don't have any sign that goes with positive and negative. So it means that here we can say that there is no local maxima, right? So B, there is no local maxima because we don't have anything that shows like the graph is going to increase, right? Good. Then what is the next thing? We need to look for local minima, negative, positive. So we have negative here, the next one is negative, so nothing happens here. We have negative, the next one is positive. Okay, so it means that there will be concave up here, right? There will be concave up here. So it means that there will be a minimum here, which is at 0. So the local minima is at x is equal to 0. So we have local minima, which is x is equal to 0. Good. So we have the local minima that we are going to get from the graph there. Now, what's the next thing that we need to do? We need to sketch the graph. Now, for us to sketch the graph, we need something small that we need to add it up before we can sketch the graph, right? So for us to sketch the graph, we need the x values, I mean the critical values. So the critical values we had -1, 0, and 1, right? So let's look for 0, -1, or -1 first, 0, and 1, right? So since we are sketching the graph for this, we are going to plug these values inside this. So we are going to have f of x, right? So when I plug -1 inside this, what am I going to get? So it's like plugging -1 inside this, what am I going to get? So plug in -1 here, it will be 1, -1 here is going to be -3, -1 here is going to be +3, -5, and this is going to give us -4. Then plug in 0. So when I plug in 0, this one will be 0, 0, 0. So it will be left with -5. So this is going to be -5. Then plug in 1. And then I think when you plug in 1, this one will be 1 -3, 3 -5. So this is going to give us -4. So we have a point. What point? We have -1 and -4. -1, -4. We have 0 and -5. 0 and -5. We have 1 and -4. 1 and -4. right? So we can even use this information that we've gotten to sketch f of x, like how the f of x graph is going to look like. So I have my y, I have my x. What are the x values? We have 0 here. Let me put 1 here, and let me put -1 here. So what's the point? 0 goes with -5. So let's assume that I have -1, -2, -3, -4, and then -5. Then 0 and -5, 0 here, -5, we are going to have it somewhere here. Then -1 and -4. So -1 is here, which is x, and then the y, which is here, so intersection. So we are going to have it somewhere here. And then 1 and -4 is 1 is here, -4 here, so intersection. We are also going to have it. This one should be cleaned up small, somewhere here. So with the idea of graph, it means that the graph is going to take a form, something like this form. So it's just a sketch. Good. So we are going to have something like this, which shows that there is what? A concave up, and we have the minimum value at 0. So we saw that at minimum, we had minimum to be 0, right? That's the local minimum. That's what you are going to get from the graph. So this is how we can go through. So what did we do? For you to find increasing and decreasing, find the critical values first, put it on the sign chart, test it from values after this one, in between this, and then after one, and check the signs. When you are done, you can also use that sign chart to do for or look for local minimum and maximum, and then you sketch the function too as well. So now let's look at question 4. Now with 4, we have a demand function for a product, right? So this is the demand function here. Good. Then the first function is to find the elasticity function in terms of P, right? So the first thing that we need here is we need to know the formula for finding the elasticity. So E of P, so E of P, we know that E of P is equal to minus P F prime of P divided by F prime. So this is one hard work that we need to do. We need to memorize the formula. Another hard work that we need to do is we have f of p, which is here, but we need to just look for f prime of p, and then we are done. So what is f of p? F of p is equal to 1200 minus 2p squared. So what is f prime of p? When I differentiate this, this goes to 0. When I differentiate this with respect to p, I'm going to have 0 minus 4p, and this is supposed to be minus 4p. Good. So now that I'm done with the hard work, I just need to do substitution, right? So I'm going to have minus p times what is p prime of f prime of p, this here. So I plug it there, minus 4p divided by f of p is this. So I have 1200 minus 2p squared. And when I simplify this times this is going to give us 4p squared divided by 1200 minus 2. Oh, this is not supposed to be 2p squared. Oh, 2p squared, yeah. 2p squared, yeah. Now, as I said, anytime you get here, don't try to cancel anything. You cannot cancel anything, right? Some people will just cancel this, and you cannot cancel this and this. Though, if you want to cancel, then here, since there is 2 here, you can factor 2 out to use to cancel, or you can just leave it in this form. But if I want to cancel, then I can write this one as 4p squared divided by, here I can factor 2 out because there is 2 here. So when I factor 2 out, 2 times what number is going to give us this? 2 times 600, right? Is going to give us what is here. Then minus p squared. So now that this 2 is out and it's multiplying this, now I can cancel this 2 and this 4. And we are going to have 2p squared divided by 600 minus p squared. Now that we have gotten in this form, you cannot cancel this 2 and this 600 here. You cannot also cancel this and this. So we leave it this form. So if you cannot do this hard work here, then you leave your final results here. That's all. All right. Let's look at B. B, we want to find the elasticity when price is 10. So here is when P is equal to 10. So when P is equal to 10, we just need to plug it in the function that we had. So if we stopped here, it means that this is what you are going to use. If we stopped here, this is what you are going to use, right? So that is the idea. So since I'm using this one, I'm going to have 2 10 to the power 2 divided by 600 minus 10 to the power 2. So this is going to give us 2 times 100 minus 600 minus 100. This is 200 divided by 500, and this is going to give us 2 over 5, right? And we can conclude here, even if the question did not ask us, since the top is smaller than the down, this will be less than 1. So we can say that, okay, this is inelastic, right? If there is any interpretation that we need to do. Let's look at C. Let's look at C. What is C? For which price value does an increase in price decreases the revenue? So an increase in price decreases the revenue. Then we are talking about elastic. That is when E of P is greater than 1. Good. It's greater than 1. So now what is E of P? We've done the hard work already. E of P is what is here. So we just need that one up there. So I'm going to have 2p squared divided by 600 minus p squared. So somebody is asking me, what if I'm using this? Am I going to get the same thing? Yes, you are going to get the same thing. When you use this and you plug in the 10, you are going to get 215. And then even the one that I'm doing here, if you also use this one, the final result that I'm going to get, you get the same thing. If you don't know how to do the simplification here. So what am I going to do here? I'm going to multiply both sides by the denominator here so that I can cancel this one out. So I'll multiply this one by 600 minus p squared and multiply this one by 600 minus p squared. So what can I see? This will cancel this. So on the left, I'm going to have 2p squared greater than 1 multiplying this is going to give us 600 minus p squared. I add plus p squared, I add plus p squared, right? So I'm going to, when I add p squared to this one is going to be 3 p squared greater than, when I add p squared to this one will go to 0, so it will be 600. I divide both sides by 3. So this 3 here will cancel this. So I'm going to have p squared greater than, now when 3 divide 3 will divide 6 2, so I'm going to have 200, and then I'm going to take square root here, so I'm going to have p to be greater than root of 200, right? So since we are not using calculator, we can leave our final results in this form. So any price which is greater than root of 200 would decrease the revenue. That's the idea with the interpretation here, right? So that is the question 4, right? Let's move to question 5. So we have 8 questions. We are on the 5th question. Let's move. Stay here with me. You will learn a lot today. So now we have a demand function here. And then A, use the implicit differentiation. We need to find an equation which involves dx over dt, dp over what? dt. So in other idea, it means that we are going to differentiate this function with respect to what? T. So with that regards, it means that our function will be in terms of what we have here. So now let's go to the A and see what we are going to do. So I have x squared plus 3p squared x minus 6p squared is equal to 12. So don't forget we are doing implicit differentiation, right? So now when I differentiate this, remember when I differentiate 2x squared, I'm going to get 2x. But here we are not differentiating it with respect to what? X. We are differentiating it with respect to t. So when I differentiate x squared, I'm going to have 2x, but I'm going to multiply by dx over dt, right? Because I'm differentiating with respect to t. Plus, now this is a product rule, right? So I need to apply the product rule there, right? So what am I going to do here? I can factor the 3 out. So, or let me say, let me just pick them and do it here, and I come and put there. P squared x. If I'm using the product rule, I can say that my A is equal to 3p squared, and then my B is equal to x. Or let me say my B is equal to x. What is A prime? A prime is going to be 6 p dp over dt. I think I need to shape this one small so that I can see it very well. So I'm just picking this. A is equal to 3p squared. What is A prime? Power rule. So 2 will multiply the 6. A will multiply the 3, giving us 6. Subtract 1, what will be left to p. But since it is implicit and we are differentiating with respect to t, I need to multiply this one by dp over dt. B is equal to x. When I differentiate x, since we are differentiating with respect to t, I'm going to have dx over dt. So now I multiply this by this and this by that. So that's what I'm going to get. So I'm going to have 3p squared times this. So this and that. So I'm going to have dx over dt plus, now I multiply this by this, I'm going to have x 6p dp over dt. So you see the way I just pick what is here, I went to do it and I brought the answer here. So if we are doing it straight, then what did I do? Product rule. If we want to do it straight without picking A and B, then you maintain 3p squared, then differentiate x, which will be dx over dt, plus, now I maintain x here and differentiate 3p squared, and I'm getting 6p dp over dt, which we differentiated and we had it here. Then minus, now when I'm differentiating this, power rule, 2 multiply the 6, giving us 12p, then I need to multiply it by dp over what? Dt, which is equal to, when I differentiate 12, I'm going to get 0. Good. So a lot of hard work. So if I just want to do something small, I'm going to have 12 2x dx over dt plus 3p squared dx over dt. Then when I multiply x and this, I'm going to have plus 6xp dp over dt minus 12p dp over dt. So the question was A, using the implicit differentiation, find an equation which involves dx over dt and dp over dt. And this is what we've gotten, which involve this is here and we have this also here. So we can leave it this form. So that's A. Now let's look at B. What is B? If price is increasing, so increasing here is a word, meaning that the change is going to be positive, increasing at the rate. So rate means that we are going to have d over dt, but the dt is going with respect to the price, right? So, and it's equal to 0.5. So one information that we are getting from B, let me write B here, is dp over dt is equal to 0.5. That's one information that we are getting. So this is the change. Rate means that d over dt. But what is it going with? It's going with price. So I put the price here. And it's equal to 0.5. The increasing here telling us that it will be positive, not negative. Right. Then when price is equal to $1, so we have another information, P is equal to 1, right? And then we have, and demand is 3,000, right? So demand is the X, so we have X2, which is also going to 3,000. And then what's the question asking us? Then find the rate of change of demand. So rate d over dt, demand X, it means that we are looking for dx over dt. So we are looking for dx over dt. So we are going to use this equation that we have here to do it, because we have given x, they've given us p, they've given us dp over dt, and then we find for this. Right, so let's write it up there. So we had 2x dx over dt plus 3p squared rather dx over dt plus, I think we had 6xp dp over dt, and then minus 12p dp over dt, which is equal to 0. Right. So with equation from A, which is the implicit, now we know dp over dt, we know p, we know x. So let's do substitution. So x is 3000. We don't know the x over the t, that's what we are looking for, plus 3 times p is 1. We don't know the x over the t, plus 6, x is 3000, p is 1, dp over dt is 0.5, so times 0.5 minus 12 times p is 1, and this one too is 0.5, which is equal to 0. So we are now looking for that. So when I multiply 2 to 3000, I'm going to have 6000 dx over dt, plus when I multiply this one, I'm going to have 3 dx over dt, plus, now when I multiply this, so 0.5, this one is like 5 divided by 10. 1 0 will cancel one of the 0. So I need to multiply 5 by 30 and 6. So 6 times 30 times 5. So 6 times 5 is 30. So 30 times 30. So let's go through 30 times 30. 0, 0, 0, 9. That's going to give us 900. So we are going to have 900 minus, so this is like 12 times 5 divided by 10, right? Good. So this is like 1 goes here, 1. So this is even half. So half of this is going to give us 6. So 6. Did I do this one right? Okay, let me do it again and see. This is like 6 times 300 times 0.5 is like half, right? So what is half of this? Half of this, so half of this is going to be 3. 3 times 6, 3 times 3 is 900. That's right. So this is equal to 0. And then this and this are the same, so we add this and that. So we are going to have 6003 dx over dt. Then when I subtract 6 from 900, I'm going to have 894 is equal to 0. This implies that 603 dx over dt, this is supposed to be dt, is equal to minus 894. So I subtract 984 here, subtract 894 here. Then I'm going to divide through by 603. It's 6003. So I'm going to have the x over the t to be equal to minus 894 divided by 6003. So this is what I'm going to get for the B too as well. Right. So now let's look at 6. Let's look at 6. So 6, we have P, right? We have P, and P is equal to this here. And then we want to find the revenue function. So A, we want to find the revenue function. So the revenue function is the quantity, which is X, times times price, right? So this is what you are going to get. Now we can see that the revenue function is in terms of X, so it means that we need to change the P. Fortunate for us, we know that P is equal to 5 minus 0.01x. So this is going to be X times 5 minus 0.01x. And we just multiply 2 by X, we get 5x minus 0.01x squared. No hard work for A. So it means that there will be hard work in B. Let's look at B. B, if the production for an item is increasing by 5 items per week, how fast is the revenue increasing or decreasing in dollar per week? when 100 items are being produced. So what we are looking for here is, now since we are talking about if production for an item is increasing, it means that there is a change, right? There will be a change, because if the production is increasing, then we need to produce more. So it means that the x over the t, because production, that's the quantity, which is x, is equal to 5, right? Good. And they've also given us something here that 100 items are being produced. Then x is equal to 100. So these are the information that we need to pick. Now, what are we looking for? We are looking for how fast is revenue going to increase or decrease. So increase or decrease. Increase means that our final results will be positive. Decreasing means that our final result is going to be what? Negative. So since we want to know that, then what we need to do is we need to look at the change. What is going to be the change when there is a price increase, or people are demanding more? So we need the R over what? The T. That's what we need. So we go to equation question A. We saw that R is equal to this. Then we differentiate it with respect to T. So now let's do that. R is equal to 5x minus 0.01 x squared. So what is the R over the T? So when I differentiate 5x, I'm going to have 5 dx over dt. So I factor the 5 out. When I differentiate x with respect to t, I get dx over dt, minus I factor the 0.01 out. When I differentiate x squared, I'm going to have 2x dx over dt, because I'm differentiating with respect to what? T. So let me move this one up there. So what will be dr over dt? We said this is going to be 5 dx over dt minus, we can multiply this to that. So we are going to have minus 0.02 x dx over dt. Is that right? Good. So now that we know the x over the t to be 5 and x to be 100, let's do substitution. So we are going to have 5. This is the change was 5 minus 0.02 x is 100, and the change 2 is 5, right? As we have them here. So 5 times 5 is going to give us 25 minus, now I'll change this one. This is like 1, 2. So this is like 2 divided by 100 times 100 times 5 is going to give us 500. So this is a way of, this will cancel this and that. So we are going to have 25 minus, so 2 will multiply, it will be left to 5 here. So 2 times 5, it's going to be 10. And we are going to have this one to be 15. So this is positive. So it means that revenue is going to increase, right? Revenue is going to increase, because since people are demanding more, then it means that the revenue should increase, because the change in demand is still positive, right? So this is what we are going to get at the end of the question. Right, let's look at question 7. We look at 8, and then we are done here. Now, question 7 is interesting. On what interval is f increasing, and on what on and or and one what interval is f increasing? This is so annoying, like when I'm reading this. So with increasing and decreasing, remember we use the sign chart, and the first thing that we need to do is we need to find for the critical values. But for us to find the critical values, we need to find f prime. This is f, but fortunate for us, they've given us f prime already, so there is no hard work. We don't need to go and differentiate this. F prime is already given. So we are going to use f prime, then we find the values of x that's going to make the function 0. So let me just do that. So let me just do that here. F prime of x is equal to minus 2x divided by x squared plus 3 all squared. So we said for critical values, they are values that make the function 0 or undefined. So the zeros one are the one on the top. So I pick the one on the top. So anytime you have derivative and you want to find the critical values, pick the top, set it to 0. So I pick the top, which is minus 2x, I set it to 0, and x will be equal to 0. Then I pick the down, I set it to 0, right? But the idea is that down here, there is no value that will make this one 0. So it means that even if I set this one to 0, this is the idea, like x squared plus 3 squared is equal to 0. When I take square root on both sides, I'm going to have 2 plus 3 is equal to 0. And since this is squared and this is positive, I'll have x squared is equal to minus 3. And this is going to give us complex value. We don't want complex value. So it means that there is no value that is going to, there is no real value that's going to make the denominator 0. So the only critical value here is what? S is equal to 0. So we can put this one on the sign chart and then we check for increasing and decreasing. So let's do that. Let's do that. So on the sign chart, I have 0. So I need to pick f prime. I can put minus 1 in. Pick f prime, I put 1 in. So what was f prime? F prime of x is equal to minus 2x divided by x squared plus 3 or squared, I think so. Yes. So that is f prime. So now let's plug in minus 1 inside this. Now the denominator will be always positive because this is squared, or everything is squared. So minus 1 squared is 1. This plus this will be 4. This one will be positive. But when I plug in minus 1 here, this one too is going to be positive. So positive divided by positive will be positive. So this is going to give us greater than 0, meaning that this is positive and this is going to increase. Right. Then what again? I need to plug in 1. This one will be positive. But when I plug in 1 here, this is going to be negative. So it will be negative divided by positive, which is equal to negative. So this is going to be minus, and this is going to decrease. So this is going to, this is less than 0. So where is increasing? So increasing interval, that is A. So now we are dealing with A. Increasing interval is, so we can see that it's just increasing up to 0. So we are going to have minus infinity to 0, and decreasing interval is from 0 up to positive infinity. So we are going to have 0 up to positive infinity. That will be the decreasing interval. So that is A. B, at what values of x does f have local maximum or local minimum? So we are going to use the same sign chart to answer that. So we said for local minimum, it should be, for minimum, it should be minus, plus, and for maximum, it should be plus, minus. And the sign should be like going up and coming down. So you see that going up and coming down, positive, minus. So that's what we have local what? Maximum. There is no local minimum, because when I draw the graph will be something like this. So this is B, local maximum is at x is equal to 0, right? That's local maximum. So there is no local minimum, right? There's no local minimum. So that is that for the B. Let's look at C. C, on what value f concave up and concave down? So concave up, concave down, what we need to do is, with concave up and concave down, we use a second derivative to check, right? So what we need to do is we need to find a second derivative. Unfortunately for us, there's no hard work to do because f prime prime is here. So we need to look for x values that will make the function 0 or undefined, then we put it on it, right? So same idea. Let's look at what is here. Now you will see that the denominator is the same as this. So it means that there's no value here that will make the function undefined. So we just concentrate on the top. So I pick the top. What is the top? We have like 6 times. So for concave up and down, f prime prime of x should be equal to 0. So 6, x plus 1, x minus 1 should be 0. So I pick x plus 1, to be equal to 0. Or if you can see, you see, somebody will ask where from the 6. The 6 I can divide 2 by 6, so I will have x plus 1, x minus 1, so that you don't confuse yourself. So x plus 1 is equal to 0, x should be minus 1, x minus 1 should be equal to 0, x should be 1. So these are the points that we are going to use to, derive the concave up and then concave down, right? So what are we going to get for the concave up and down? So I have something like this. So we use the sign chart. So I have, so I have 1, I have minus 1, I have 1. Was that right? Yes, that's right. So what are we going to do now? Don't forget, we have something like 0 here, but 0 is just for those kind of things. So let me pick f prime prime. I'll pick minus 2, f prime prime. Here I cannot pick 0 because 0 is a local maximum, so I can pick something aside 0, right? But let me see when I plug in 0 if you are going to get the right thing. Yeah, so we can also plug in 0. Let's plug in 0, and here we can plug in 2. If any other thing, we can also plug in let's say 0.5 here, right? So something like that. So now let's plug in minus 2 inside this. So as I said, always this is going to be positive, so we are interested in the top, whether it's positive or negative. So minus 2, when I plug in, is it minus 2? Yeah, minus 2. When I plug in minus 2 here, minus 2 minus 1, minus 2 plus 1 is going to be minus 1. Minus 2, this is going to be minus 3. So minus minus will be positive. So positive over positive, and this is going to give us positive. So this is like greater than 0. This is going to increase, right? And then I pick 0. When I put 0 there, unfortunately for us, is going to be negative. So this is going to be negative, which is also concave down, right? Good. And then when I plug in 2 here, 2 here is going to be positive, so positive, positive, and I'm going to have this one to be positive. Good. So that's what you're going to get from there. This is 1. Now, this is what you're going to get. So now where can we see the concave up and concave down? The concave up is going to happen here. Concave down is going to happen here. And then concave up again is going to happen here, right? So concave up concave upward or up is going to happen. The interval is going to be from minus infinity up to minus 1, and then from 1 to positive infinity, right? So concave up is going to happen here, right? And then concave up is also going to happen here. So here we check the signs: positive, concave up, positive, concave up, and this one is going to give us concave down. So we are going to have concave down here to be from minus 1 to 1. So that is where the concave up is going to happen. So between minus 1 and 1, there will be concave down. Like concave down is like you are going to have seen something like this, right? So between here, you are going to see something like this. And between here, we are going to see something like this, right? So the graph is like you having something like this and like that. So here is concave up, this is concave down, and this is concave up, something like that. So that's what you're going to see from there. Good. So let's look at the last one. The last one, we want to sketch the graph, right? We want to sketch the graph. So sketching the graph, what are the values that we have here? We have x equal to minus 1, 1, and we have 0, right? So you see that 0 So for us to do this, what we need to do is we need to find the corresponding values for the functions. So what is x values? We have 0. So f of x is when I plug 0 inside f of x, what am I going to get? This will be 0, this one will be 0. So I'm going to have 4 and 3. Now let's check the values for the concave up and down. I have -1 and I have 1. When I plug in -1 here, I'll get 1. So 1 plus this one will be 5, 1. This one too will be 4. So I'll have 5 on 4. This one too will be 5 on 4 when I plug in 1. So how is the graph going to look like? I'll just draw it something small here for you to see. So I have this one here. X values, I have 0 here. Let's assume that this is let's say 4 on 3. So I'll have 1 point somewhere here with 0, right? And then -1 here and 1 here. And let's say 5 on 4 is 1 point something. So this is going to be like, we are going to have it somewhere here. So let's assume that here is 5 on 4. So we are going to have let me bring this people here small. So we are going to have something like this. So let me bring -1 close, 1 close. So we are going to have the point here and this point also here like this. So the graph should look something like this, coming down like this, right? And then this one too coming down like this. So it's kind of as we said, in between this is the concave down, right? There will be a concave down, which it means that it will have a maximum. So that's the concave down. Then from -infinity to 1 is like concave up. So from this to this one is like concave up, like this. Do you get it? And then from 1 to positive infinity is like also concave up like this. Yeah. So this is how the graph should look like. Right. This is how the graph should look like. Right. So that will be the D. Let's look at the last question on the sheet, which is question 8. Question 8, we have equation here, and we want to find dy over dt at this point if dx over dt is equal to this. So this one too is very nice. We need to use the implicit or differentiation. So we have 3x squared y cubed plus x to the power 4 is equal to 25. So since this is with respect to t, it means that we need to differentiate this with respect to t. So the first function here is a product rule. So let me assume that a is equal to 3x squared and b is equal to y cubed. What is a prime? A prime is going to be, use the product rule, the power rule, 2 multiply 3. So you're going to have 6x dx over dt because we are doing implicit. And then b prime will be equal to 3y squared, then we multiply by dy over dt. Right. So now let's use the product rule here. This multiply this, this multiply this. Any of them works because it's addition. So we are going to have 3x squared times 3y squared dy over dx plus y cubed and then 6x dy over, no, dx over dt. So what did I do is, like, if we are doing it straight, I maintain this function here, differentiate y cubed, and then I have this. Plus, I maintain this one, differentiate this, and I have that. Plus, when I differentiate x to the power 4, I get 4x to the power 3 dx over dt, right? And when I differentiate 25, I get 0. So this is the hard work. The rest is just simplification. So I know that this point, since we are here in the slope function, this is my x, this is my y. I have also the x over the t. So I just need to find for dy over dt. So let me simplify something small before I can just put them in. So when I multiply this by this, I'm going to have 9x squared y squared dy over dx plus 6xy cubed dx over dt plus 4x squared dx over dt. is equal to 0. So since all the information is given, I just do substitution. So 9x is minus 1. What is y? Y is 2 squared. We don't know the y over, this one should be t. Sorry. I love writing the dy over dt, right? So this one should be t, then plus 6 times x is minus 1, y is 2. Then we know the x over the t is minus 3, right? Plus 4 times x is minus 1. And then we know that the x over the t is minus 3. This is equal to 0. So when I simplify, 1 minus 1 squared will be 1. 2 squared will be 4. So 4 times 1 times 9 is going to give us, I think this one should be 36. Yes. dy over the x, sorry, the t. Then minus 1 times this is going to be 3. Or let me say 2 to the power. Okay, so let me just write it small here. So this one will be plus 6. This times this is going to be minus, it will be 3. 3 times 6 is going to give us 18. So let me just write 18. And then 2 to the power 3 is going to give us 8, I think. Yes. Then let's see what happens here. 1 squared will be positive. So this time this will be minus 12. Minus 12 is equal to 0. Good. So what are we going to get? Let's multiply 8 to 18. 18 times 8. 8, 64. I add this one to 8 times 1 is 1. 8 plus 6 is going to give us 14. So 144. Is that right? Yes, that's right. So we are going to have 36 dy over the t plus 144 minus 12 is equal to 0. This implies that 36 dy over the x, and when I subtract 12 from this, what am I going to get? Plus 132 is equal to 0. So let's do the final work on the top. So 36 dy over the x dt was plus 132 is equal to 0. Let's check if it is true. Yeah, 36, 132. So I'll subtract 132 here, subtract 132 here. So I'm going to have 36 dy over the t to be equal to minus 132. And then I divide through by 36. I divide through by 36. So I'm going to have dy over the t to be equal to minus 132 divided by. You can leave your final results here, or you can also do some small cancellation. So 2 can go into this, I think, minus 6, 64, I think. Now it's 66. Yes. Yeah, so 2 can go there, 66, and go to 36. I think 18. Yes, I think so. Yeah, it should be 18. Yes. And then 2 can go to 6 again, 3, and go to 18. I think 9. Then I think 3 can go to 3, 11, and go here 3. So the final result should be minus 3, minus 11 over 3. So this is the final question on the worksheet or the exam review. So the next video that you are going to work on will be full exam video, like exam 2 questions, and we will see how the questions are being framed and how we can go through together. Right. So see you in the next video.